Well, good morning, good afternoon, everyone, and welcome to today's Exploring by the Seat of Your Pants event. My name is Joe Grabowski, and I'll be your host for today. As we make our way through October, about the halfway point right now, we still have lots of live events coming your way. Every October, we celebrate space exploration, connecting with astronauts and engineers and scientists who are exploring beyond our planet into the solar system and further on into our universe. But of course, they're also turning a lens back at our planet so we can explore it and look at it in ways we never could before. So if you head to exploringbytheseat.com, you can find all of the live events still to come. Register to tune in live, grab a camera spot, or get a link so you can watch the recorded events later. So we hope to see your classrooms joining us as October continues. So today we are going to continue that space exploration action with a little virtual trip to our red planet and the Curiosity rover. So today we have Dr. Abigail Fraeman joining us. She's a research scientist at NASA's Jet Propulsion Laboratory and the deputy project scientist for the Curiosity Mars Rover. So she studies the origin and evolution of rocky bodies in our solar system and has worked on robotic missions to Mars, the moons of Mars, and Earth's moon. So today we're going to get a little update on the latest news from Curiosity, learn about some of the mission findings, and maybe hear some personal stories about how Abby became involved in space exploration. So I'm going to reach backstage and see if I can get Abigail in here with us. Hey, Abigail, how you doing?
Hello, I'm good. How are you?
Excellent. Well, it's great to have you with us. You're a veteran of many Exploring by the Seat of Your Pants space exploration presentations. So we always love stealing some of your time.
Oh, wonderful. I love speaking with you all.
Great. We've got classrooms in Canada and the US joining us today. If you're on YouTube, don't be shy. Use the chat sidebar. Let us know where you're tuning in from. We'll play a little Kahoot later probably and get into some Q&A action. But for now, Abby, I'm going to let you take over for a bit.
Fantastic. I will pull up some pictures that I'd love to share with you as I talk to you about my job working on Mars.
Okay, I see them loading.
Does that look all right?
We are full screen. Good to go.
Wonderful. Well, thank you again so much for having me. I'm so excited to talk to you all today to tell you a little bit about my job as an explorer exploring the surface of Mars. I'm talking to you today from where I actually sit, which is in my office in Pasadena, California. It is a town right outside of Los Angeles on the west coast of the United States. And I work at a place called the Jet Propulsion Laboratory, or we like to abbreviate it JPL. We're actually one of several centers that make up the whole organization called NASA across the United States. Different centers focus on different things. So you may be, heard the phrase, Houston, we have a problem. That's talking about the Johnson Space Center in Houston that manages all of the astronauts. A lot of the launches that you might see from NASA happen at the Kennedy Space Center in Florida. But here at JPL, our specialty is robotic exploration of the solar system. So if there's a place humans haven't gone yet, but we still want to explore, we're the people who really want to build the mission for you and help you explore with a robot. So JPL has built missions that have gone all sorts of places in the solar system: Mars, Saturn, Jupiter, asteroids, lots of things to explore. But of course, I'm going to talk to you today a lot about my other office, which is on Mars, the red planet. This is our closest neighboring planet, the fourth planet from the sun. And this was my view out the window, actually, last Friday when I came into work. This is a picture of where the Curiosity rover was on Mars. This is a black and white image from the rover's navigational cameras that we get every time we make a plan for the rover. And we use images like this to figure out where we are and what we want to do during any given day on Mars and where we want to send the rover next. We're in a particularly interesting place on Mars where there's these kind of weird rocks and ridges and hollows. You might see them scooped out. And so I'll tell you a little bit about that at the end of the talk. But before I get into that, just kind of stepping back and telling you about why I'm so interested in studying Mars and going there for my job. And I think there's some really important questions that we can answer by looking at our neighboring planet. One of the biggest questions is this question of, are we alone? Which I think is one of the most important questions that we can ask as humans. At the moment, the only life that we know exists in the entire universe that we've ever discovered is what we have on our own planet, planet Earth. We know, though, that Mars, like 3.5 billion years ago, was really similar to what Earth was like at that time. And we also think that's about the same time that life formed and arose on Earth. So the big question is, if the environments and the processes were the same on the two planets, did the same process that formed life on Earth also form life on Mars? And today, of course, Mars is very, very cold. It's very, very dry. We don't think there's life on Mars today, at least not on the surface. But we're really interested in understanding if maybe 3.5 billion years ago, there was ever life on Mars, and did it start like it started on Earth? And of course, if we find the answer to that is yes, that's a really important thing to know, because we know there's thousands of planets in our galaxy around other stars. And so if we find there's life on two planets in our own solar system, that means there's probably life that's pretty common all throughout the galaxy. Another reason it's so fun to study Mars is because it really is a place that we can imagine humans visiting one day. Um, I think that's the ultimate in exploration, to be able to send scientists to Mars to walk around, to really look at it, to study it. But before we're able to do that, we need to understand the kind of things that the astronauts who go to Mars would face. What are the environments like that they'll have on the planet? And what are some things that they might be able to find when they're there that they could use to help them survive? Things like water resources that they might be able to use instead of bringing all of the water from Earth, which is very, very heavy. We can answer questions like these, both what do humans need, what can they find, and was there life on Mars, using the field of geology, looking at the rocks on Mars to find out what they're made of and what stories they tell. Here on Earth, I get to do some geology, and I get to go to Mars-like places to study the rocks and see what they're like, places like Hawaii or Iceland. Or I just got back a month or so ago from the desert in Oregon, looking at lots of lava flows. And when we do geology on Earth, we can bring a lot of tools to help us look at the rocks, things like rock hammers and hand lenses. We can pick up the rocks, look at them, bring them back to our lab. It's a little bit harder to do that with Mars at the moment because we don't have humans there. So instead, we do geology on Mars with our robotic explorers. Now, there's two kinds of robots that we've sent to Mars. There's a whole fleet of orbiters that we've been sending there since the 1970s, which have orbited the planet and collected information about its surface using cameras and other instruments that can measure the composition, that can look for ice, that can measure the temperature. But my favorite way to explore Mars is by the robots that we've landed on the surface, either as landers that land and sit in one place and can do things like scoop up the soil and analyze it, or rovers, which can drive around the surface and explore, see what's beyond the horizon. It was actually rovers that got me interested in this field of, we call it planetary science, in the first place. And the real rover that made me want to study Mars and become a planetary scientist was the Opportunity rover, which landed on Mars back in 2004. And this was one of the first pictures that Opportunity sent back from the surface of Mars. And it just blew my mind when I saw it for the first time. I was 16 years old. I was in high school, a junior in high school. And this was just such a different view of Mars than we had ever seen before from anything else that landed on the surface. What you can see here is a lot of really dark black sand. A lot of the sand on Mars is actually black because it's made up of broken up bits of volcanic rock. And poking out in the distance, you can see these light colored rocks. That's actually something that geologists call bedrock, which is rock that is where it formed, in place where it formed. And this is so exciting to geologists because it gives us a lot of information about the history of that specific place, because we knew those rocks formed where they were. This was a picture taken from the landing pad where Opportunity landed, but because Opportunity is a rover, we actually got to drive off the landing pad and get really close to those bedrocks, and we found that they were formed in the presence of liquid water, which is one of the ingredients that we know life needs. And so this was a monumental discovery in our search to understand if Mars ever did have the conditions that could support life. I'm not going to talk a whole lot more about Opportunity, but I will let you know that if you're interested in learning more, there's a wonderful documentary that's on Amazon Prime that's called Good Night Oppie, and it tells the whole story of this mission. You might recognize a familiar face about halfway through. That's me who shows up. But it really talks a lot about what it took to get Opportunity to the surface of Mars and then what she found during her 15-year exploration of the surface. But we're now in 2025. And so our rovers have actually grown quite a lot from what we were able to do with Opportunity. And I work on the rover now called Curiosity. And here's a nice rover family portrait of the rovers that NASA has sent to Mars. The first one was the little Pathfinder rover you can see on the bottom there, followed by Opportunity. And then there's Curiosity, which is much bigger, much more complicated. And the reason for this is because we're using the rover to answer even more difficult to answer science questions. What Curiosity is doing is looking to understand whether Mars ever once had habitable environments that we know life could have lived. And we define 3 major ingredients that we need to look for to find a habitable environment. One is the presence of long-lived liquid water, which we know was there because of what Opportunity found. But also we wanted to find things like molecules that had carbon in them, which are called organic molecules, the building blocks of life, and potential sources of energy that little ancient microbial life on Mars could have used to help feed themselves and power themselves. And so all of the instruments on Curiosity are designed to be able to answer those questions. This is one of the first images that Curiosity sent back after landing. When this image came back, I was a graduate student. I had been inspired by Opportunity to study planetary science and was at school learning how to drive rovers on Mars, and actually got to be a part of the Curiosity team the night that the rover landed and got to see this picture come back. And to me, it's just as inspiring as the Opportunity picture was. It once again shows a whole new side of Mars that looked different from anything we'd seen before. In this picture, the really important thing to note is way off in the distance, you can see something that looks like a mountain. And it is a mountain. It's called Mount Sharp. And what Curiosity planned to do was to land on the really flat surface next to the side of the mountain and then drive to the mountain and drive up the mountain. And the reason we chose this mountain to explore was because we could see from orbit that it was made of lots of different layers. And in fact, I'll take a little chunk of this mountain and then zoom in with our telephoto lens. And this is what it looks like. And if you look closely, you can start to see some of the layers that are in the rocks. And it turns out this mountain is made of a rock called a sedimentary rock, which are rocks that are built by wind or water. And what's so exciting about these rocks is you can actually look at what's in them, what their shapes are, what minerals are present to help you understand what environments formed them. Was it a dry environment with lots of sand dunes? Was it a volcanic lava flow? Was it a watery, wet lake or a stream? And so the idea was we'd land at the bottom of this mountain and then drive our way up to the top. And as we do, we'll be looking at rocks that get younger and younger and younger and younger. And we'd be able to see how the environments of Mars changed from wet to dry to wet to dry. We didn't know what we would expect, but it was something we'd be able to discover. It's kind of like if you were to go to a place like the Grand Canyon in the United States. If you go to the bottom of the canyon and then you hike your way up, you're walking forward in time and you're seeing a snapshot of the history of the Earth as you look at those rock layers. That's exactly what we're doing on Mars with Curiosity. We can also tell from orbit that the layers have different minerals in them, which tells you that they preserve all kinds of different environments. So things like salts, which usually form when you have a much drier environment, things like clays that form when you have a lot of water, and then things like iron oxides, which are basically rust, which also sometimes form in the presence of water, but don't always have to do that. We landed back in August of 2012, and just as a spoiler, we're all the way high up on the mountain now, over 900 meters we've climbed, and so we've learned a lot about the history of Mars. This is just a fun graphic of Curiosity in action and artist representation, and just a chance to tell you about some of the instruments that we do have on the rover to answer these questions about, was Mars once a habitable planet? Of course, the coolest instrument, I think, is the laser that we have on the top of the mast of Curiosity, kind of sitting on the head. We use that laser to vaporize the rocks, and we can look at what their composition is by looking at what comes off in the vapor. There's also very special a drill on Curiosity, and we use the drill to drill into rocks and make a powder of the rock, and then deliver it into two onboard chemistry instruments. So Curiosity really is a mobile chemist here. And this is part of the reason the rover is so big and so complicated, is to accommodate these instruments that tell us if there's these organic molecules in the rock. What are the minerals that are present in the rock? What's their crystal structure? I also think it's important to point out that we do have a very important instrument on Curiosity that was contributed by Canada, and our science team is made up of scientists from all over the world, including a lot from Canada, who operate an instrument on the arm called the Alpha Particle X-ray Spectrometer, which is quite a mouthful. We call it the APXS for short. But we use this instrument also to tell us more about the composition of the rocks and what particular elements are in them. This is a picture of almost all of the drill holes that we've collected with Curiosity over the mission. All of these holes, they're maybe like a centimeter across and 4 to 6 centimeters deep. So not super big, but definitely enough to collect the rock powder that we need to analyze the rocks. I really love this picture, first because it just shows how successful we have been at drilling robotically on Mars, which is very hard to do, and really impressed that we've been able to drill so many rocks. But also that this image shows just how colorful Mars really is. We think about Mars as being the red planet, but it turns out when you blow away all the dust and you look beneath the surface, Mars is actually a green planet and a gray planet and a red planet and a purple planet. And all of these different colors of the rocks tell us about the different minerals that are present in the rocks, which is related to how they formed and the different watery and dry environments that the rocks formed in. This is a sketch that shows what our journey has been like over the last 13 years. That white line shows the path that the rover has taken. We landed in the flat area next to the base of Mount Sharp at Bradbury Landing and made our way up to the mountain. And so we're all the way up where you might see the label that says boxwork structure. That's what we're investigating right now. This represents over 36 kilometers of driving, or more than 22 miles, and over 900 meters of elevation that we've climbed up the mountain, or over 3,000 feet. Right when we first landed in this area near Bradbury Landing called Yellowknife Bay, this is what it looked like. Again, you can see Mount Sharp there in the distance waiting for us. But even before we got to the base of the mountain, Curiosity made a really exciting discovery. We found the rocks on the floor of this area were made of lake deposits, essentially clay minerals that had been slowly settled out in a lake that was probably around for a good amount of time. We could tell by the minerals that were there that the water was something that would have been drinkable and would have been great for life. And drilling into the rocks, we were able to find these organic molecules and this potential kind of molecules that energy could have used for life. So right away, we already found that Mars was once habitable even before we got to this mountain. But as we kept climbing higher and higher, once we reached the mountain, we kept seeing that these lakes were still around, which told us, the higher we climbed and the more lakes we found, that the lake was probably present for millions, if not tens of millions of years on the surface, which was pretty cool to see. And oh, like 7 or 8 years into the mission, we got pretty high up on this mountain into an area where we saw a pretty dramatic change in the rocks, where we went from these lake deposits, which are shown as those light colored rocks on the bottom, into these different kinds of rocks that we didn't know what they formed. These were the rocks we could see from orbit were associated with salts. And you can see in the image how they look quite different. They're darker colored. They form these kind of hills and buttes and mesas. And so it was a really exciting time to see what happened on Mars after the lake dried out. This is just a beautiful view of Curiosity as the rover was driving through all of these buttes. They made spectacular scenery just to look at and see what a cool planet Mars is. But for the geologists, they were also really helpful because we could look at the sides of these buttes and see the layers in the rock. And they told us about how they formed. And what we actually found was that these rocks, the majority of them were sandstones. They were coarser grained and they had different patterns in them that told us that these rocks were formed by sand sheets and sand dunes and sand ripples, and basically showed us an environment where Mars started to dry out and the lake was no longer here. It was a much drier area where you were kind of more like a desert where you might find a lot of sand, but it wasn't all dry. We found some features like this. This is looking down at in front of Curiosity, and it's something we call a workspace. And you can see there's these big kind of lumpy bumps on the rocks. These are actually nodules that formed when you had groundwater moving through the rocks and making new minerals. And we could actually drive over these with our wheel and crush them open and measure their composition. And we found that these were really salty nodules. And so this told us that even though it was mostly dry, we still had some water that was around in the subsurface of Mars and could have been a place where life could have gone and persisted even after the lake disappeared. And as we climbed higher, we found another really weird looking layer that was unlike anything we'd seen already. And it was this kind of dark rock. It kind of looks like a lava flow, but it wasn't. When we were able to look up close at this layer, we actually saw all of these wavy features in the rock. And this is what it looked like on top. This is actually what we call wave ripples. And they form when you have, a shallow body of water that's being blown by the wind and sloshing back and forth. And you form these really characteristic patterns. If you've ever been to the beach or at the shores of a lake, you might see something like this forming in the sand, these ripples. And so even though we went to a period in Mars's history that was mostly dry, it wasn't entirely dry. You started to get water that was reappearing and forming maybe shallow lakes that came and went. So a really cool understanding of the history of Mars and what happened as it transitioned from a place life could have lived to the cold, dry world it is today. This is just another pretty picture I like to show. This is one of the images we took looking uphill at all of the different layers that Curiosity would drive through and get to explore. This was something we found just about a year ago. We were in a big channel that cut through the layers, and we stumbled upon these really strange looking white colored rocks. This is what one of them looks like up close. This doesn't look like any Martian rock I had ever seen. 20 years of looking at pictures of the surface of Mars, I have never, ever seen a rock like this. We were really surprised. As I've already shown you, we like to drive over rocks to break them open, to look at them, to see what they're made of. And so we drove over one of these weird white rocks. And when we looked inside, actually, we could see the rock was a little bit yellow and it was crystalline. And when we put our instruments on it and we were able to figure out what it's made of, we found that this is actually pure sulfur. It is just sulfur crystals, which is something we've never seen before on the surface of Mars, and a really exciting discovery. And I just think it's so cool that we're finding new things. Even though we've been exploring Mars with rovers for 20 years, there's still so much of the planet that we haven't seen and understood yet. This was a little video we took just sitting on the surface, a day on Mars, which I like to see the sun going across the sky and you can see the shadow of the rover. This is one of the cameras that we have underneath the rover that helps see hazards as we drive. And to me, it makes Mars really feel like a place. So I'll go ahead and wrap up just showing you where Curiosity is today. This is an orbital image. The white line shows where we were planning to start our, we call it the 5th extended mission. Curiosity has been going on way longer than we originally planned. And so every couple years, we write a plan for what we want to do for our next extended mission. But you can kind of see that white line goes through all of these kind of spider web looking things. Those are actually big fractures that are tens of meters long and meters wide. This is what they look like as we were approaching them. And then this is what they look like today. We call them the boxwork structures because they look like these boxes and they have these ridges and hollows, and it's a really strange looking terrain. We think groundwater also played a role in forming these features, maybe cementing the rocks and the ridges a little bit more than the hollows. And over billions of years, the rock eroded to form this. But we're not entirely sure what that groundwater was like, what was its composition, how did it work? And so what we're doing now is investigating these features, looking at their chemistry and their structures, and we're actually just about to hopefully drill into them on Friday to try to figure out what else we can learn about them and how they formed. Looking ahead, here's where we're headed next, these big light-colored features in the distance. I have no idea what these rocks are. From orbit, we can't tell what they're made of, but they're certainly going to tell us something about the history of Mars. Can't wait to get there. And then I'll just wrap up by also noting that in addition to geology, we've been doing measurements of the environment on Mars, the temperature, the pressure, the humidity, the radiation environment, which is all sorts of information that will hopefully help future astronauts understand the environment. One of the cool things we discovered was that certain times of the year, we get these clouds that form in the Martian sky right at sunset called noctilucent clouds. And this is a picture of those clouds. And I could just imagine setting up my tent, camping at the base of this feature and looking up at the sky as these clouds come out at sunset. And just a really nice thing to be able to think about. Here's another view of the clouds where you have these light rays shooting through them. This is a feature called crepuscular rays. Sometimes they're called God rays, but I think it's just beautiful. So I'll end it with just another postcard that we recently took as we were exploring, and the motto that we have here at JPL, which is dare mighty things, and thinking about how much we have yet to explore in our solar system. If we just put our minds to it and work together, and we can build these wonderful exploration vehicles. So with that, I will go ahead and wrap up, and happy to take any questions.
All right. Awesome, Abby. Thanks for that great presentation. I love all the visuals, giving us a look, what it looks like on Mars. Very, very cool. We are going to get to some Q&A action. So if you are tuning in via YouTube, don't be shy to send us some questions there. But before that, we're going to play a little Kahoot together. So I'm going to share my screen, and it's going to look a little bit like this. There we go. And we'll start it up. If you would like to join us today, you need to visit kahoot.it. So the website you're looking for is kahoot.it. Then it's going to ask for a PIN number. Today's PIN is 71006. So you can shout out your answers to your teacher. If you're joining from home, you can even scan that QR code with your phone and join us that way. So we'll give a few seconds to see if we get some groups joining us. I'm looking backstage. It looks like I see some students trying to join on their laptops. So we'll give them a little bit of time. And in the meantime, we'll start off. There we go. Here come some students. We'll start off with a few questions to get things rolling. So Abigail, first question I want to start off with. We connected not too long ago with one of your colleagues, Ashwin, to talk a little bit about rovers on Mars. And I'm wondering, what do you think? What's your best guess for how much longer Curiosity is going to be on the move and sending back data?
Good question. We hope many, many years. We have a power supply will hopefully be the rate limiting factor of the rover, we're powered by this radioactive plutonium, and we can measure how that decays over time. And we think we have many more years that we'll be able to squeeze out operations. Now, of course, on Mars, you never know, and something could break any day, and we can't go up to Mars to fix it. So any day could be our last. We do our best to do the best job we can taking care of the rover.
All right, we'll squeeze in one more question because I do still see some groups trickling in. So, you mentioned things potentially breaking. There's all kinds of sensitive gear on the rover. I'm wondering if there's a piece of gear that's maybe given you and the team the most trouble over the course of the mission.
Yeah, for 13 years on Mars, the rover's in remarkably good shape, but we have had a couple things break. So the really famous one is the wheels. The wheels are really, really thin. They're made of aluminum, and they're about the thickness of 6 aluminum cans. And it turns out when you drive those over really hard, sharp, pointy rocks on Mars, they get holes in them. And so our wheels have some holes in them, but we've done a lot of work to change the way we drive and really monitor them carefully. And we think they're still going to last for as long as we need them to. A couple other things have broken, like some of the joints on the arm, but we have backup joints, so that's okay. And the computer, we have 2 computers on the rover, and one of them is kind of fritzy, but we've been on the other computer for most of the mission, and it's been working okay.
All right. Well, I think we can play some Kahoot now. There are 5 questions today. There's some true and false, some multiple choice. As always, the quicker you put the right answer in, the more points you're going to get. Here we go. First question coming your way is a true or false question. NASA JPL specialty is sending humans into space. You got about 20 seconds to lock something in. Get those answers in quick. At NASA's Jet Propulsion Laboratory, their specialty is sending humans into space. Is that true or is that false? About 5 more seconds to lock it in. All right, good job, crew. It is robotics, sending those unmanned missions into space. Let's take a look at our leaderboard. The gentle axolotl is holding down that top spot. We've got a multiple choice coming your way. Mars is the blank planet from the sun. Is Mars the second planet from the sun, the 4th planet, the 5th planet, or is it the 8th planet from the sun? So what do you think? Is Mars the second planet, the 4th planet, the 5th planet, or the 8th? You've got a little extra time because there's a little more reading and thinking for this question. But remember, the quicker you get something locked in, the more points you're going to get. So the 2nd, the 4th, the 5th, or the 8th planet from the sun. All right, good job, crew. It is the 4th planet from the sun. The gentle axolotl is holding on. We're going true or false. 3.5 billion years ago, Mars was pretty similar to Earth. So what do you think? 3.5 billion years ago, roughly, when we're getting some life on Earth, Mars was pretty similar as well. Is that true or is that false? You have 7 seconds to lock something in. And all right, true is absolutely right. Good job, crew. Now, Abby, we know that there was very likely a big ocean on Mars. What do we think happened to all that water?
Yeah, we're not totally sure. It's one of the questions we're trying to answer. Some of it is trapped in the rocks. Mm-hmm. Some of it was lost to space, and we're trying to figure out how much and where it all went.
All right. If we look at our leaderboard, the Power Rhinos powered their way into first place. We have another multiple choice coming your way. You have to pick the one that doesn't belong here. So what types of robots have we not sent to Mars? Is it rovers, ROVs, orbiters, or landers? You have a picture decoding, which should give you a pretty big clue here in a second. But which robots have we not sent to Mars? Rovers, ROVs, orbiters, or landers? You still have 10 seconds to lock something in. I think our picture clue is going to give things away now. All right, it is those remotely operated vehicles. We use those here on Earth when we're exploring in our ocean, but we haven't sent any to Mars because the water just isn't there on the surface like it used to be. Power Rhino holding on. Final question, true or false? Curiosity's traveled about 36 kilometers on Mars. So what do you think? True or false? Curiosity's traveled about 36 kilometers. You have 13 seconds to lock something in. Is that true? Is that false? Let's see what we come up with. We'll take a look at our podium, and then we are totally going Q&A action after that. All right. Whew, we were a little split on that one, but we lean towards true. So roughly 36 kilometers, so just over 20 miles on the surface of the red planet. Let's look at our podium. In third place, we've got the Radiant Wolf. In second place, the Proud Blackbird. And holding down that top spot, do we have a new leader? Ooh, we do. The Awesome Mink sliding in and stealing our Kahoot game right there at the end. Very cool. Okay, let's turn off that screen share. Let's turn off that music. Thanks for playing along with us. Let's get into some Q&A action. I see lots of people tuning in on YouTube, so don't be shy. Use that chat sidebar. Send in any questions you do have for Abigail. And we're going to reach backstage and start pulling in some classrooms. We'll get some of their questions. I'm going to start off. Whoops, I switched my page. Let me try that one more time. There we go. We're going to go to Texas. We're going to find some third and fourth graders and see what they're thinking here. Let's get them into the call. Hey, third and fourth graders, how you doing?
Good.
All right, we're ready for some questions. Let's go.
My name is Gus and I'm in third grade. My question is, how far away is the Earth from Mars?
Oh, that's a very good question. How far away is the Earth from Mars? Well, the Earth is about 93 million miles from the sun, and that is a unit we call 1 AU. Mars, I believe, is about 1.5, 1.6 AU. So if we take about half the distance from Earth to the sun and we add that, that's about how far away Earth from Mars is.
All right. What do you think? You got another question there for us?
Yes, we do. Hey,
Here comes someone.
hurry up, go. My name is Faith and I'm in third grade, and my question is, how long did it take to get the rovers from the Earth to Mars?
Yeah, Mars is far enough away that it takes a long time. It takes many, many months. So usually it takes around 6 to 9 months to get from Earth to Mars, but only if you launch it when Earth and Mars are as close together as they get. When they're on other sides of the sun, it would take a lot longer. So usually we only launch things every 2 years when Earth and Mars are as close as possible. And yeah, that's when it takes 6 to 9 months to get there.
Oh, thank you.
All right. Well, good questions to start us off. We'll check in with you in a little bit. Before we grab another classroom, Abby, the landing, getting Curiosity onto the surface of Mars was pretty wild. Can you tell us a little bit about that process?
Yeah, great question. So Mars is far enough away from Earth that it actually takes a pretty long time for any signal from Mars, a communication, to get to Earth. So it takes about 7 to 10, 15 minutes, depending where you are, for a signal to come. The whole time it takes to land on Mars, where you hit the top of the atmosphere going 13,000 miles per hour to when you need to be on the surface, it only takes about 7 minutes. So if you kind of do the math on your head, by the time you hit the top of the atmosphere, by the time you get that signal, it'll be 10 minutes later, everything will have already happened. And so all of the sequences for the landing have to be completely automatic. We can't joystick it down because the signal just takes too long. So what the engineers here at JPL developed was something called Sky Crane to land this 1-ton rover on the surface of Mars. And it was all automatic. And what happened was they had the rover basically on a upside down jetpack. And the jetpack helped slow the rover down as it went screaming through the atmosphere. And then when it got pretty close to the surface, we lowered the rover on a tether from this jetpack sky crane situation. And we're able to very gently place it on the surface of Mars before we cut the tether, and then the jetpack went flying off into the distance. It was pretty cool. It was pretty scary because we didn't know if it was going to work or not. And if something goes wrong, you don't have time to fix it. But yeah, there's a picture of what happens. So you hit the top of the atmosphere. First, you have a heat shield to protect you from the heat. That gets jettisoned at one point. You have a big parachute to slow you down, but can't slow you down all the way. So that's when we have this big sky crane, or the upside down jetpack, that lowers the rover to the ground and then flies away. So we've now landed 2 rovers successfully with a sky crane, both the Curiosity Mars rover and its sister rover Perseverance, which landed about 10 years later.
All right, very cool. I think that's such a cool way to put a rover gently down on the surface of Mars. So much to think about, to test, to program, and then just crossing your fingers once it enters the atmosphere and hoping for the best. That's pretty cool. Okay, let us visit another camera classroom, then I'll take some more questions from YouTube. We have some grade 5/6s in Petrolia in Ontario. Let me grab them from backstage. All right, 5/6s, let's get that microphone turned on. Let's steal some questions.
Did you mean Tom Thompson from Burlington?
Oh, okay. Yeah, that'll work.
Okay, I have some students here with some questions.
Okay, how long does night last on Mars?
Yeah. So Mars is super cool, where its day is actually really, really close to the Earth's day. So the Martian day is just about 45 minutes to an hour longer than an Earth day. They have about a 25-hour day. So night is just a little bit longer on Mars than it is on Earth. Makes it both easy and hard to operate the rovers, because you can almost do it on Earth time, where the rover will do everything it does during the day, and then it goes to sleep at night to recharge the battery. And then we here on Earth plan what activities we want to do the next day. But because the Martian day is just a little bit longer, our schedule shifts by about an hour every day. So the Martian night, when you first start, maybe it co-aligns with the Earth's day, but then it gets later and later and later. And pretty soon we're making plans in the middle of the night. We don't do that anymore. It's hard to do that for 13 years, but it was something we did when we first landed, called living on Mars time, which was great fun.
All right, 5/6s. You have another one handy there for us?
Yes, we do. We have one more here.
Perfect.
Hi. What else did you find in the rocks on Mars?
Wow, we found all sorts of cool things. So we found a lot of neat minerals. We found a lot of clays and salts. There are minerals called sulfates. We found some what's called halite, or basically table salt. So if you were to lick the rock, it would taste salty. We've found a lot of evidence that there was deep groundwater on Mars that lasted a long time.
All right. Thanks, 5/6s. Great questions. Let's shift over to YouTube now. So we're going to start off. We've got a virtual elementary school hanging out, and they have a few questions here in the chat for us. But let's start with, there's lots of planets, there's lots of moons in our solar system. Why Mars? Why do we keep sending stuff to Mars?
Yeah, there's a lot of really cool stuff in our solar system. And let's give a shout out to some of those moons, because I think the moons are super cool. We have some moons around Jupiter and Saturn that we think have these subsurface oceans in them. So, when you think about ROVs, we can't send them to Mars, but man, it'd be cool to send them to like a moon of Jupiter to get under the ice shell and drive around in this ocean. But Mars, I think, is exciting. First of all, it's our closest planet. It's a lot faster and easier to get to Mars than it is to get to some of these other places, which take years and years to get to. So it's just a lot harder to send things and wait and wait and wait before you get there. So it's hard to send as frequently. Mars is also exciting because it's, it's a little bit less expensive to get there. So potentially you can send things there more frequently that are cheaper than it takes to get bigger places. And then, there is this idea that humans might go to Mars one day, and it's hard to imagine them going to other places. And so thinking about getting ready for that, I think, is something that's exciting. And then I'll also add, Mars is a pretty special place compared to any other place in the solar system. And a big reason is that the rocks on Mars are really, really old. And there's nowhere in the solar system, not Earth, not Venus, where you have rocks that are preserved that are that old. On Earth, they're all destroyed because we have these plate tectonics that recycle rocks. So if we want to go somewhere, a planet, and learn about what is a planet like when it first forms 4 billion years ago, and see how the atmosphere changes and how the magnetic field works, Mars is the only place we can go to get at that record.
Okay. Elena is in grade 2, and Elena wants to know about how big is Mars?
Yeah, Mars is tiny. Mars is smaller than Earth. It's about the third the size of Earth. If you take all of the land on Earth but get rid of all the oceans, that's about how big Mars is.
Okay. So you mentioned Mars is close, so it's a little bit cheaper, and we're thinking about sending people to Mars. This question here on YouTube is wondering, do you think within the next 100 years we'll have people living on Mars?
Oh, I sure hope so. I think it would be really cool. I don't know about permanently living there. I think it's a pretty tough place to live, but at least going there to explore and to learn, what an amazing opportunity. There's still a lot of challenges we need to figure out how to get humans there, how to survive, but I think it's worth going. I think there's so much we could learn by sending humans there.
Okay. One more question from Mars, then we'll do a quick check-in with our camera crew before we say goodbye. Seasons. Are there seasons on Mars?
Yes, there are seasons on Mars. Mars's axis is tilted like Earth's is, and that's one of the reasons we have seasons on Earth. But Mars, the way it orbits the sun, actually, it's a little bit more, we call it elliptical. So there's periods when Mars is closer to the sun and further to the sun, and kind of combination of those things is what makes seasons on Mars. I can tell you where Curiosity is right now, we're just getting out of winter and moving towards springtime. Makes operating the rover a little bit easier because when it's winter, it's really cold. We have to run a lot of heaters that take a lot of power. So I'm looking forward to moving into spring and summer soon.
All right, awesome. Well, let's check in with our camera groups one more time. Texas, do you have another question for us?
No, Sue, stand up.
My name is Kara Sue, and I'm in 3rd grade. And how much longer until people can live on Mars?
Yeah, I don't know the answer to that question. I know a lot of people are really excited about it, and we're doing some work, but there's still a lot of work to go. But it would be really cool if it's in my lifetime or certainly your lifetime. And it's really cool if one of you gets to go to Mars, or maybe several of you get to go to Mars one day. I think that'd be pretty awesome.
Yeah, very cool. I think we'll see the moon first. I think that won't be too far off in the future. We'll be doing more things on the moon. And then that's a good jumping off point to make our way towards Mars. Pretty cool. Thanks, Ms. Paget's crew. Thanks for those awesome questions today.
Okay, thank you. I guess we don't get another.
You can grab another one if you want to sneak another one in.
Okay, go
I
ahead.
love questions.
My name is Dallas, and I live in Cherokee. How do you all make the robots?
Yeah, they're really hard to make. They're one of a kind build robots that are designed specifically for the Martian environment and to last a long time. So we build them at JPL and then working with companies all around the world to help with parts. We design the rovers. We make sure that they'll be able to fit what we call requirements about how they need to operate. And then, yeah, we build them. Actually, building right across the street from me is where they actually physically put all the pieces together, build them, test them really carefully to make sure they'll survive shaking during launch and all sorts of things. And yeah, it takes thousands of people to design and build a rover like Curiosity.
All right. Thanks, Dallas. Good question. Okay. Tom Thompson 5'6". Do you have another follow-up for us?
I think we're good. You've answered a lot of our questions. Thank you so much. We really
Perfect.
appreciate your time.
All right. Thanks, crew, for hanging out with us. Okay. Let's wrap up with one more online then. Okay. Here we go. This is obviously a class in Canada because they want to know, on Mars, does it get colder than it has ever been in Canada?
Yes, it gets quite cold, especially in the winter at night, like minus 200, really, really cold. But there are some times in summer on Mars where it is colder in Canada than it is at the equator of Mars where Curiosity is exploring. In fact, there's even times when it gets colder in the United States than it is on Mars. So there are certainly times you've been in Canada where it's been colder where you are than where Curiosity is, which is pretty mind-blowing, I think.
All right, very cool. Well, I want to start off with a huge shout out to our classrooms, our backstage classrooms, as well as the cool crew who joined us on YouTube. Thanks for those awesome questions. Thanks for playing along with that Kahoot action. And then Abby, thank you so much. Thank you for updating us on Curiosity. Thank you for giving us a little bit of your time. I know there's lots of good science going on, so we really appreciate getting to hang out with you today.
Wonderful. Thank you so much for having me and for asking all those wonderful questions. All
right. Well, we had a small crew backstage today, but a lot on YouTube, but we can still bring in our crew to get a goodbye and thank you. Thank you so much for hanging out with us today. It was awesome to see you. There's our 5 6s. Thanks, everybody. And we are going to sign off for now. We'll see you later in the month.
All right. Thank you.